Hello, everybody. Good morning and good evening from Switzerland and Australia. Welcome to this masterclass with Dr. Andrew IP from Australia. My name is Holger Kast. I'm the head of training education at TRI, and I'm leading you through this webinar. Let me start. The topic is today Scan and Smile in 15 minutes. So we have a series of webinars. That's already the second one this time. And before I pass the word to Andrew, I would like to introduce you a little bit about this Scan and Smile in 15 minutes. So we are TRI. By the way, before I forget it, we have the rule, if you have any questions during the webinar, we can pass them in the field questions, and we will have a question and answer session at the end of Andrew's presentation. And so let me introduce you for a few minutes into the TRI implant company, in the number one digital implant company. Our goals are completely clear. We focusing our workflow every day on Think Digital. We are a digital-based implant company based in Switzerland. Swiss quality is really important. Our production is in Switzerland. We create a very great and high performance every day. And simplicity, I think simplicity is for me always something of the most important things in the system, because I will introduce you to the digital implant, the matrix implant. And the matrix implant is the world's first implant where you do not need an abutment anymore, which simplifies the life of any dentist very much. And in total, our digital-based company and our digital-based implant system is an open system. So we work with the main companies which provides you, for example, when we start with an implant planning, we work with the main companies to plan your implant cases. Followed by the patient digitalization. We have an open system. That means you can work with your chosen CBCT scanners or face scanners and so on. We provide you for no money the data and the files to use any of those companies. And this follows by manufacturing. So we work with the open milling machines. We work with open CAD and CAM systems. CAD and CAM, the CAD CAM design software is mostly ExoCAD or 3Shape. And today we talk about AI design, which is not ExoCAD and not 3Shape. We will talk more detailed in this presentation. And then the treatment is clearly we can go fully guided with the system, but also we are able to use the robotic navigation systems, which might be the future of implant placements. So the matrix implant itself offers you 8 unique patterns, and it's a unique connection. Sometimes people ask me what system is compatible prosthetic-wise to the matrix implant. We don't have abutments anymore. We don't have hexagons, octagons, or anything else anymore. We have a specialized connection which is made for milled zirconia final restorations, and also in the future for 3D printed final restoration, because we strongly believe that 3D printing prosthetic will be a big future in implantology or in dentistry. So you can see on this picture already this connection. It's a very smooth and designed 20 degrees angulated connection. And I just added here a quick video. You see now from the top of the implant connection, now you see a crown, and this crown is maybe 3D printed, maybe milled, and you can see a thick, strong 35 Newton centimeter tied up prosthetic screw, which you can use for single crowns, but also for full arches. And imagine, I just said like 35 Newton centimeter strong, torqued prosthetic screws for full arches. This is opening a new chapter. Also for full arches, you do not need abutments. We can mill or 3D print in any angulation of your implant placement into this implant connection, and then we screw retain, not with little small screws with 15 Newton centimeters, we screw retain with 30 Newton centimeters. That's a quick picture to the multi-level implant. The Matrix multi-level implant is the most used implant in the portfolio. You can see we have a concave design here. That means you can place this implant classically like a tissue level style, but you also can play with this multi-level height in this pink area. So you can even place the implant up down to the platform of the cortical bone. And sorry, that was too fast. And this concave design gives you a perfect emergence profile, and you have no cement line for any tie bases. That means you have anatomically and biologically a lot of advantages to use an abutment-free system. This is leading me to this next slide. We are really proud. We have now a 5 years special edition casebook. So if you are interested in this casebook, because it shows you different cases over the last 5 years since we placed the Matrix implant in the patient's mouth, with top doctors and professors, for example, Professor Ronnie Jung. Check here the QR code and you can download this casebook and watch all those results and the follow-ups over 5 years. I just want to mention 2 cases here. This is the first case from a good friend, Dr. Joel Telles from Portugal. He placed a very tricky case already 5 years ago, and you just can see, and I think pictures say more than words. You can see here on the left side 2 months and then 5 years result with a screw retained 2 zirconia crowns in super aesthetic zone. And you can see, since there is no gap, since there is no tie base or any abutment in between undercuts, and so it's polished zirconia, we have absolute fantastic bone results after these 5 years. Another thing, I talked about full arches. We can do full arches very nicely, especially for FP1 cases. I think the system is absolutely great in a fully digital workflow. And you can see here all these cases in this 5 year special edition. You can find it on our website or with this QR code. So going into this 15 minutes transformation into a smile. How is this possible? So this is more or less the workflows. You place the implant, you do an intraoral scan that costs you maybe 5 minutes, maybe only 2 minutes if it's an easy case. And then you have an STL file. This STL file you would feed into an cloud-based software and this AI crown software. And Andrew will explain you that much more detailed like I do right now. But you drop just this STL file in there and the AI-based software will get you an STL file of the crown immediately. There's no need to add a patient's name or something. It just gives you an STL file. You can work on this STL file. You can make it bigger, smaller, or wider. But then you take this STL file, you drop it in an nowadays printer. In this case, it was the Midas printer. It prints you in about 7 minutes a crown. And then you just screw retain this crown in the patient's mouth in our days as a temporary, but there's materials out, and I'm quite sure also Andrew will talk about materials which maybe you get used for final restorations. Quickly, a video of the Professor Ronald Jung from the University in Zurich who used this system. And this is how fast things can go. You extract the teeth, you make an immediate implant placement. You need for sure maybe a pilot guide as it is done here. And then you have to reach a certain height of torque. I would say like up to 35 Newton of primer stability for this implant placement. And then you can add the scan body, and in the time you're scanning, or in the time the scan is done, the doctor is able to do some bone grafting, as you can see it here now in this video. And now the 3D printer is already running, and after the crown is then printed, you can place this crown, and this will come in a few seconds in this video. You can place the crown. And so there's also the design. I jump here a little bit quicker because Andrew will show that. So this is the STL file done by this AI software. And then you can place the crown in the patient's mouth. That's, sorry, a little bit too long for us. Here we can place the crown, and you look how aesthetic this 3D printed crown can look. And this is the look already after 1 week of a 3D printed crown in aesthetic zone. The AI crown design software you can download on our website. You can sign up for an account, and this is the QR code for it. But I'm also already knowing that Andrew is showing you this QR code again. Coming to Andrew IP. Andrew IP, he's joining the Matrix system and TRI team since already also 5 years. We talked about it yesterday. This is one case he did already many years ago. And I thought, like, when I saw this case in that time, that I really talking to a pioneer of 3D printing. And Andrew, he started in this time to place a case with a single crown, but also had a click veneering. You can see that here on the left side, veneering to have an aesthetic single crown, fully 3D printed. And that was when the journey with Andrew started, when we said, like, okay, we as a digital implant provider, we have to work with Andrew. And so I'm very happy to introduce you to Andrew IP, who is a dentist in Sydney. Actually, you're sitting in Sydney. That's what you told me. You have 2 clinics in Sydney. And as I already said, you are working with several 3D printing brands. You're a speaker for them worldwide. And I'm very, very excited for your presentation. Please go ahead, Andrew, introduce yourself and share your screen. Thank you.
Thanks for the generous welcome.
So,
right. Start mine.
Okay, yeah, we can see it. It's perfect.
Beautiful. All right. So tonight, well, where I am, it's nighttime, but you may be it may be morning for you or afternoon for you. For the Aussies out there, really, I mean, thanks for rocking up at 10 p.m. I know it's a hard thing to do, especially if you've got family, but I hope you take something out from today's webinar. So today's webinar is really about 3D printing and how artificial intelligence feeds into this very unique implant system, which is the TriMatrix system. If you want any further information on what I do, these are my details. You can follow me on my socials, or you can check out my website and my YouTube channel. So a bit about me. So I'm, as Holger mentioned, I'm based in Sydney. I work across 2 private practices, and I've done a lot of postgraduate education, not just on implantology, but of course, digital dentistry, orthodontics, the whole lot. And I guess I'm known as the 3D printing guy, or one of the 3D printing guys in Australia. So I do operate currently about 4 resin 3D printers, a filament printer. I've used the ceramic printer before. I think the current tally of printers I've used is about 40. And when I first started, I started off as a hobby. It was none of this evidence-based learning. You just rock up on the internet. You check out Facebook groups, and you kind of like learn as by yourself. And all the mistakes that you can make in 3D printing, I've made them myself. Well, most of them, I would say. And yeah, these days I review 3D printers. I'm not really tied to any specific brand, so yeah, it keeps me busy. And I think this is the tally of 3D printers that I've used so far. So I've hit the big 40 this year. So let's get right into the meat of the topic. I think before we go into AI and new methodology on how to provisionalize implant treatments, I think we have to appreciate what is the current status quo, or what we can potentially do right now. And the TriMatrix implant system is quite unique in the sense that there is no abutments that we need to be concerned of. And in fact, the Tri guys are very generous. They do give access to this library of 3D printable or millable healing collars, which you can mill or print in-house. And this is basically an example where I've got 2 3D printed healing collars that are printed out and polished and placed on the same day as implant placement. And this is basically the results that we can get from it. So not bad. considering that it's not a truly customized option. So it's certainly better than just your standard healing abutment or healing collar. These are printed out of Ceramco Crown Tech, I think at the time, and polished to a high shine. So you print them out of some sort of temporary or definitive crown and bridge resin out of any printer that you have access to, or you can melt in PMMA, it's up to you. I guess the important thing is that you must polish any tissue contacting surface to a really fine shine, and you must never use glaze on those surfaces that contact soft tissue. So yeah, it's not a bad idea if you don't have anything and you don't want to do your own design work. This is all pre-made. You can make a whole bunch of these in advance and then just sterilize them or autoclave them and then pick the one that you want to use on the day. I think it's not a bad option for many users out there to get started in some basic CAD, well, more like basic CAM. Of course, you could go for something like this, where this was an interesting patient, and I'll go through this case in a bit more detail next. But here I had a very anxious patient. So we had to do everything or as much as possible before implant placement, certainly before tooth extraction. So what we did was we had an intraoral scan, of course, a CBCT. We merged those two data sets together. And on ExoPlan, we're designing that surgical guide based off some implant planning. And I'll speed through this video because I don't want to bore you too much. But here we're just kind of like merging the two data sets together. Here we're just putting a basic tooth and all right. Cool. Now we're basically placing our proposed implant. So this tooth actually had a vertical root fracture, which I'll show in the next slide. And yeah, once again, please note that this is all done beforehand. We haven't even raised a flap yet because this actually all has to be done under IV sedation. So really everything had to line up, and we got lucky, I guess, in this case because everything was really planned perfectly, and we had a good amount of apical bone for excellent primary stability, which of course, which is what we want in an immediate provisionalization case. Right, so we've planned the implant placement, and now we're basically going to design the guide. And yeah, here we do digital extraction of the tooth. And then, so if you send your, your cases off to a lab to design a guide, this is basically what they do. All right. So here we're marking the margins of that surgical guide. And of course, once the margins are marked, it's quite easy to create that surgical guide. So I won't bore you with that because that's not really the focus of today's webinar. So that's the guide. All right. Now, using that proposed implant placement, we've actually, I actually designed an immediate provisional, and it's not going to be perfect. The beautiful thing about ExoPlan and ExoCAD is that the two softwares actually merge together very nicely. So you can do something like this. So we're basically designing, we're planning implant placement. Based off that plan, we're designing a surgical guide. And based off the initial, implant placements digitally, we're designing a provisional restoration. So this is all made beforehand. And it's not going to be perfect, as I mentioned, but it doesn't really need to be. It's just a temporary. We can realign it. We can add remove material to this particular provisional restoration. So that's basically what it looks like. Okay. And then, of course, we print the surgical guide. This is being printed on, I think, the SprintRay Pro 95S. Nowadays, I use a Pro 2. Of course, wash, cure. That's the guide. And then, of course, we're basically printing the implant provisional here. All right, so there's a lot of steps, okay? And I would say the big hurdle of this step is actually the planning and the design, which is why AI is becoming more and more popular, because a lot of these simple tasks are not necessarily replacing the entire CAD process, but they're making our lives a lot easier. And I'll show you later how they do that. Right. And this is basically the case. No, and when it all lines up, it's fantastic. And I think I did get a really good result overall in this case. So you can see it's very hard to see the split in this particular tooth, but it is there. You can see the extracted tooth there. That's all, done under IV with this pre-made surgical guide, fitted in there, done our osteotomy and placed our implant. Great primary stability, which is what we wanted. So we placed that trimatrix implant. And then with that pre-made implant provisional, we've basically inserted it on the appointment, the same appointments. Patient is still sedated and doesn't know what we've been doing, but she's had a lot. She's had a tooth out. We placed an implant and we placed a provisional restoration. And this was all done in that 90-minute appointment. So when it all lines up, it's fantastic. But, and I say but, the problem with making all of this digitally before the procedure has taken place is that if my implant placement wasn't spot on, it wasn't quite what it was supposed to be, then pre-making that provisional would have put me in quite a lot of trouble if it didn't fit. So you always kind of have to know how to fix your problems before you really embark on something like this, which is why these days I don't pre-make my provisionals as much. Because my printers and my design work is a lot faster now, we can actually do it during the procedure, which you saw Professor Jung do in his particular case shown earlier. Because you just basically take a mid-procedure scan and use that as the true position of that implant. Right, but let's take a step back. Why 3D printing? And I'm a big fan of 3D printers. I mean, everyone who knows me knows that. But I think 3D printing or additive engineering, additive manufacturing is very, very valuable in many practices globally. And do you know why I think that is? Basically, to get into 3D printing, it's, I think, still very cost effective. Many practices and many offices can afford to get into 3D printing, whereas the bar to get into, let's say, milling is a lot higher, simply because the cost of hardware is just that much more. The beautiful thing about 3D printing is that, I can print multiple things at the same time. So it's got multiple, restorations, single tooth restorations. Usually I can print them at the same time. Whereas if you're milling multiple restorations, anyone who owns a mill knows that it's going to take some time, all right? Maybe if you have CEREC, you're milling one crown, it's not such a big deal. But when you start adding multiple units, that's when, it does start to take a lot of time. And it's not like how it was, when I first started with 3D printing, where you'd have to do a lot of calibration. It was very technical. You'd really have to know what you were doing with 3D printers and almost like have an engineering background. I think we're quite spoilt for choice these days. I think modern dental 3D printers are very consistent, very reliable. I will go through a couple of examples or recommendations where to start from if you are looking into 3D printing. But these days, you can get some fantastic results from a lot of different companies. I think we're really spoiled for choice these days. As our technologies have improved, it's funny. When I first started 3D printing definitive restorations about 5 years ago, we 3D print crowns in about 25 to 35 minutes. Nowadays, we can print the same file in a stronger material in less than 8 minutes in many situations. So we really have come a long way when it comes to our materials that we use, the hardware that we use, and as well as the software. It's such an amazing thing. Where else, which other industry can you kind of get such a drastic time improvement in such a short period of time? So it's like almost unheard of. And of course, with AI, the entry level to get into CAD, so computer assisted design, is much lower. You don't necessarily need to have ExoCAD or ExoPlan. You could have, there are other options out there in the market. So first of all, with 3D printing, an example why 3D printing really shines compared to, let's say, an analog way of doing things. models. That's the basic thing. Taking a physical model, it's going to take a good operator about 2 to 5 minutes to take an impression. Someone has to physically pour up that model, and that's going to take about 15 to 20 minutes. And that's a very labor-intensive, hands-on exercise. You have to wait for the plaster or the stone to set. That's going to take about half an hour, maybe a bit more, maybe a bit less. And then you're going to remove, or someone's going to remove that plaster from the impression. And hopefully you don't have any teeth that have chipped away. You don't have bubbles. You don't have distortions. And yeah, it's a big conundrum if you're pouring up models. Whereas digitally, intraoral scan, 5 minutes. I think 5 minutes is actually heading towards the slow end these days. I think if you're skilled, you can really do a full upper and lower scan in 2 minutes or less. Model preparation takes about 2 to 5 minutes, depending on how fast your PC is. And often that software is free. You can send that job off to print, and that will take about half an hour. And, the beautiful thing about sending it off to the printer is that you don't need to sit and watch your printer do the work, right? You can be doing something else, or your assistant can be doing something else, or your technician can be doing something else. It's a very hands-off workflow. Of course, once it's printed, wash, cure, and realistically, there's no issues with bubbles, distortions, especially if you're using like some sort of validated workflow. And you can print, heaps of models at the same time. So specific printers available for same appointment or same day workflows. And I do have to differentiate the difference between the two. Because same day, there's many options out there. There's heaps. Pretty much nowadays, any dental 3D printer can do same day. But same appointment is a different story. All right. Same appointment means that you need, really high consistency, high reliability, without sacrificing speed. And you realistically want to print these restorations in less than 10 minutes. All right. So less than 10 minutes for posterior, a little bit more for the anterior teeth. And so there's right now, probably in my opinion, 3 good options out there in the market, but this realistically is going to change. I think there's going to be a lot more options within the next 6 to 12 months. Not 6 to 6 years. I think a lot of manufacturers are going to come up with similar products out there in the market. So wherever you are in the world, there's going to be something for you, based on your budget and what you have access to. So what's currently available, I think these are really, in my opinion, the 3 big players when it comes to same appointment 3D printing. So printing of restorations in less than 10 minutes. All right. First of all, you have to get Sega print pods. Haven't been officially released yet, but I've had the luxury and privilege of testing out this system for the past couple of months. The beautiful thing is that you can use your existing Sega hardware, whether it's a Max 2 or an Ultra. You just basically buy the accessory, which is less than 500 US. And then you just load it up onto your existing printer. So you don't need to buy a completely separate unit. That's, the one disadvantage that the Split Ray Midas has, which I'm sure many of you have heard good things about, is that it's basically a standalone unit for restorations at this stage. The Dentafab Sega is a nice and very interesting printer from manufactured, I think, in Turkey. Very, very fast. It's like a Fast and Furious unit, and it doesn't rely on any pods or cartridges or anything like that. So it's a nice versatile unit, but it's not, I guess, the easiest printer to use. Realistically, with the print pods per print, you could probably fit maybe about 1 to 2 crowns or 2 to 3 onlays or 3 to 6 veneers within that one little build plate. It's just very, very small, about maybe half an inch wide. Similarly with the Midas, it's a very small build area, 1 to 2 crowns, 2 to 3 onlays or 3 to 6 veneers. And then the beautiful thing about Midas this year is that they're going to be releasing multi-Midas capsules. So you can basically print a segment or a row of restorations. Of course, with the Dentafab, you can fit basically more than 12 restorations into one build plate. Doesn't matter. Cost per per pod for the Sega pods is about 20 to 30 euros or 20 to 30 US. Similarly, that's the price of Midas capsules. That's Crown HT. And of course, I'm not sure what the pricing will be for the multi Midas. And with the DentaFab Sega Pro, there's no cartridges, there's no pods, so you just basically buy your bottles of resin. The Sega print pods would be probably the slowest out of the three options. I think the Midas and Sega Pro really are ridiculously fast. You could be printing, restorations in as low as 5 to 6 minutes, anterior restorations in about 10 to 12 minutes. I think the print pods you have to kind of add a couple of minutes, but we're still looking at less than 15 minutes for a restoration, whether it's anterior or posterior. Asiga and DentaFab are both open systems, so you can more or less use whatever resins that you want. Whereas with Sprint Ray, you're kind of locked in to what they choose, what they feel is suitable to print on the Midas. So it's basically a closed or selected library. Print pods and the DentaFab Sega will use heat, whereas Midas is very unique. It uses pressure. So theoretically, it can print resins or slurries that have high ceramic content, which is really important. You're basically planning for the future where Sprint Ray will probably be releasing a more highly filled resins. So resins or slurries that are filled with 70 or maybe even 80% ceramic filler content by mass. And yeah, I mean, with versatility, Asiga and DentaFab are always going to be quite versatile or very versatile printers, whereas with the Midas, it's quite purpose specific or application specific. So you're really looking at just restorations. With multi-Midas, you can print surgical guides, snap-on smiles, things like that. Right. With Asiga, beautiful, it's open, it's the pods, you can use it with current Asiga hardware. If you use the pods, you can use them constantly until they break, or you've wasted your resin, and it comes with a purchasable wash accessory. But it's not as fast. The company Asiga relies on third-party manufacturing, and it does require for Asiga printers a newer locking mechanism. So you may need to talk to your distributor about that if you have one of these older Asiga units. Midas, I mean, look, Sprint Ray is really kicking butt when it comes to material developments purely because of that unique DPS technology that it has. I think the software with Midas is super easy to delegate. You can train your DAs and support staff to use it. Really, it's the king of delegability. And problem is that, of course, these capsules are single use. The library is, of course, closed, and realistically speaking, the applications are still to this day quite limited. Of course, our DentaFab Sega, very versatile unit, very fast. I think it's probably one of the fastest, if not the fastest, chairside printer in the market. It doesn't rely on any disposable cartridge or dispensing-based systems, so that's fantastic for the environment. But it is not really a true end-to-end system, so it doesn't have a wash unit, it doesn't really have a curing unit associated with it. It does rely on Tutorbox, which is a general purpose slicer as its software. So that's not the easiest thing to use for someone who wants to use something super easy. This unit may not be for you. I think if you have previous 3D printing experience, I think this is a very fun printer. I think it's a very nice printer, but it's certainly not the easiest printer to use at this stage. So we're going to combine those pieces of hardware with the tri-matrix system, and Holger did go through this earlier. And what makes the tri-matrix system unique? It has a very unique connection. As Holger mentioned, there's no hexagons, no octagons, there's no gons, right? There's no sharp corners. And the problem with sharp corners is that they're very hard to mill predictably. So you can see, in this photo, is the connection area is basically completely rounded. So it's very easy for us to mill or print. After being now, I think it's over 5 years now in the market, this system is now essentially integrated with all the popular CAD programs. You're looking at, Exocad, 3Shape, the lot. Having no abutment really is a game changer and is basically the most defining thing about this implant system. You do not need to worry about an abutment interface. Basically, your restorations are designed to be fitted straight to fixture. And so you do have to change your mentality a little bit. It was admittedly a bit of a leap of faith at the start when I first started this system, but I've been there since the start when it was first released in Australia. So I've got a good 5-year data on my own patients that the system works. It works well, and I think once you get your head around it, it really actually is easier, in my opinion, to use compared to other systems because you don't need to worry about an intermediate interface, which is the abutment. Right. So software. There's a lot of things out there in the market, and honestly, these days, a lot of them actually utilize AI to some extent. Like you've got exocad, you've got InLab, 3Shape. We'll talk about Denbird later, but got Blue Sky Bio, Medit, lots of different options out there. So I'm a clinician, and realistically, this is not going to, I'm not a technician. I do a lot of design work, but realistically, as a dentist, as a clinician, if I'm going to do any design work, I really need to make sure that it's easy to use and it's fast. So even though I have been trained in exocad, I'm starting to rely more on simpler programs that are rich in AI functionality because it's just easier for me to use, right? And I'm very comfortable using software, but a lot of you listening, you may not be. So I think this is where AI is making leaps and bounds, where it's making it or almost like democratizing CAD workflows because we no longer necessarily need to spend tens of thousands on 3Shape or XCAD. Not saying that they're bad, but there's other options that are more affordable for general use out there in the market that with a little bit of practice, you really can make them work very well. And I'm not going to go through this table in a huge amount of detail, but it's just to give you an idea how much variety there is out there in the market. There are programs like exocad and 3Shape, which are very expensive, but they're very comprehensive. So if you really want to go all out, then that's the way that you should go. Otherwise, you have simple programs like Medit, Clinics, the True Suite, simpler programs that are a lot more affordable, but probably a lot more easier and less confusing for the clinical user. It's something for you to think about before you really make the plunge and invest in really some expensive software that you may actually not use 50% or 60% of all the functions. So yeah, as I mentioned, with our current, the status quo of current software, a lot of software, and as with anything in dentistry, there's a dental tax associated with it. Dental software is expensive. Often you must install it on your PC. So you have to have like some sort of dedicated laptop or PC to operate this software. And the learning curve is exponential, right? It's really, really high. And realistically, as a clinician, where we build the most is actually placing implants, treating patients, communicating with patients. That is what we are good at. That's what we've been trained to do since dental school. CAD is often a different beast, and often we simply do not have the time, patience to invest and learn all of this, right? So software can often be like super, super simple or super, super complicated. And it's very hard to often find something in between. Right? And as I have personally, experienced, often I've invested in exocad and realistically, I don't use many of the functions out there. So a lot of that investment is essentially wasted. So where does AI come in? I think it would be quite dangerous to completely rely on artificial intelligence, but currently I think AI is very helpful in speeding up the design process and essentially giving us a little bit of a shortcut, right? It essentially removes some of that manual labor and improve some predictability in our design work, but also our CAM, our milling strategies, our printing strategies, where we place supports in 3D printing. Actually, it's not just involved in the CAD process, but it's huge in our CAM, so our manufacturing as well. It's everywhere. So and I think that's a good thing. This is a new age, and I think we have to adapt to a new way of performing dentistry, and that involves being in front of a screen more often. So Atomica AI is an example of some software that uses AI, and I'll show you kind of like how it works in a sec. But I like this program. The Trimatrix system and the TRX guided kit is already pre-validated onto this particular software. Okay, so if you're a current Tri user, then it's all there. You don't need to input your individual settings. So once again, less guesswork. Atomica AI is very well known for surgical guides. They're very well known for stackable guides. So if you're interested in that, I mean, I won't go through that, but if you're interested in stackable guides, I'd reach out to them as well. They got, 2 AI engines, one for CAD, so for your restorations, and one for surgical guides. And they use a combination of AI and algorithms and automation. So it's not purely AI, right? So I know it has AI in the company name, but it's not completely AI. So where AI is used is, in your STL and DICOM alignments, they'll detect kind of like bone density and kind of like almost like you have an option to place your implant in an ideal bone quality. It's kind of like a bit gimmicky function, but sometimes it works quite okay. And its auto segmentation tool is actually really cool and actually pretty nice. So this is Atomica AI. And so basically here, we're going to load our CBCT DICOM files. Essentially, we've got a plan and implant case. So it'll automatically kind of like detect the curve, and if you want to adjust it, of course you can. And you even have the option of auto detection of nerves as well. But once again, as I mentioned, I wouldn't completely rely on AI. I think we're not quite there yet, but it's really exciting to be in this field and how fast it's improving. We're not talking years anymore. We're talking about months. Software like this gets updated, every 2 to 3 months. It's really quite insane to see how fast this has moved. So here, I think I'm plotting the nerve manually, but of course you do have an option of auto planning or auto locating the mandibular nerve if you so wish to speed up this process instead. All right, so here we're basically placing our implants. Of course, try because this is a try webinar. And as I said, all your fixtures are already there. Plonk it in. Of course, you have the option of letting the software plonk it where it feels it's the right place. But sometimes I like to have a bit of control in the situation. Yeah, you can try it, but I would never fully trust it. Right, so we place the implant there, and then of course we're using the TRX guided kit as our drill kit system. And of course, for medical legal reasons, if you want to report on the guide, this is your protocol report, so you can export that. Now, based off that plan, we can now design our guide. And yeah, you can see the automatic segmentation. I basically click a tooth and bang, it's like it's identified the teeth. So it's just I can plot out my tooth-borne guide super quickly with this. It's probably one of the best softwares out there when it comes to auto segmentation of teeth for surgical guide design. I think actually better than some of the more expensive options out there in the market. So credit to the developers at Atomica AI. So here in pink, I'm just basically allocating the borders of that surgical guide. And then it's basically created it. And then if you want to crop out windows, it's super easy. Bang, just like that. Super, super easy. So yeah, I think it's an export-based program. So you just basically pay per surgical guide. Right. So Dentbird AI. If you want to learn more about it, there's a QR code on the screen. Otherwise, it's on the Try website as well. And this is basically the AI crown function or app for Try. And it's not just for implants, okay? You can do inlays, onlays, crowns, single unit implant bone restorations. I think you can even do bridges as well, up to 3 units. It's cloud-based, so beautiful. You can use it on the go. You don't need to have it preloaded on a PC or a laptop. There's no dongles. It's purely browser-based. Okay, so you can use it on Mac, I believe. You can use it on Windows. If I'm wrong, forgive me. But yeah, you can basically use it on essentially any browser as long as you have good, stable, solid internet access, right? And you can basically get single unit design within 10 to 15 minutes, depending on your geographic location. Now, the internet in Australia is, I'm going to say it right now, rubbish. Our internet infrastructure down under is not good. I think in parts of Asia, parts of Europe, you have excellent internet coverage. So it's quite likely that you'll get your designs much faster than what I do in Australia. I think with the internet that I have in one of my practices, a couple of times it crashes, or it just it's offline, a couple of times a month, right? So Deadbird AI is basically AI driven design of single unit restorations, be they implant born or single tooth, right? And of course, with the Tri Matrix system, it's all preloaded onto their portal. So we'll go through a case, and I really, really like this case. I think Hog actually showed a part of it earlier. And this is actually a continuation of that particular case because this patient ended up having some crowns, and then one of those crowns basically fractured at the gum level, which of course is a very unfortunate situation and a very stressful situation for everyone involved. But I like this case because it actually gives well, it'll give you a really good comparison between how I do this in Exocad compared to how I do this in using Dentbird AI. It's almost like a split mouth study. So it's a very unique case. Anyway, so we had this fractured 1-2 upper right lateral incisor. And what we were going to plan to do, of course, is take out the tooth and place the implant in and take a mid-procedure intraoral scan, design the restoration, and fit it in same appointment, right? All in the one appointment. Okay, so here, this is the initial PA. Oh, sorry, if you hear my cat meowing in the background, that's Minnie. Right, so surgical guide. Okay, this was planned in Exoplan and designed in Exoplan, and of course, this is the provisional that I've designed. So yeah, this is basically the provisional that I've designed. All right, so that's of course, it all looks good. Day of surgery. So this was pre-made, this provisional surgical guide. This surgical guide was printed out of Key Guide on the Frozen CS Plus. So great printer, doesn't cost an arm and a leg. Great printer. I think many of you who are well known with Frozen, you know them for their consumer grade printers, but they also have a dental specific printer, which is the CS Plus. So this was a surgical guide printed on their printer. I pre-printed the provisionals here using the Asiga crown kit. I think this was using Bago Trinique, I believe. All right, so on the day of surgery, okay, we've taken out the tooth as fine as possible, fitted the guide, beautiful, it fits. All right, we've done our osteotomy, as you can see, and then we placed our implant, and then we've inserted that that provisional. And I think overall it looks very good. The TRX system is a fully guided system. So basically we place the implants fully guided. And it's worked in my situation. It's worked in my favor in this situation. But as I mentioned before, the issue with making it beforehand is that your placement of your implant has to be basically perfect. Otherwise, the corresponding provisional restoration that you've pre-made may not fit. And then, you may be in trouble. All right. But in this case, of course, it's worked out in my favor. Right. So that went well. Then, all right, several months pass, and guess what? The same patient has actually buggered up his left lateral incisor this time, right? So you can even see the same provisional on the right-hand side still there, okay? And now he's screwed up the left lateral. So of course, we do suspect some sort of bruxism parafunctional habits underlying, and unfortunately, a night guard was provided, but he wasn't compliant. So of course, this has happened on us. So his patient is actually very, very understanding, and so we have to fix up this situation. And this time we're going to do everything in the one appointments. Right? So we've done our guided osteotomy, and then we've taken an intraoral scan. And with our intraoral scan, I've used Dentbird AI to design this restoration. So the patient is still in the chair. All right. So I've placed my implants. I've taken a mid-procedure scan with a scan body, and then I've loaded that up onto the AI Crown app, and away I go. And we're going to go through this design. So here we go. We load up our files, and you can see, you can even see the bleeding there. So, and the software will basically, you probably don't see anything happening, but it's kind of loading, and it'll kind of like identify or do its best job of identifying the upper, lower models. Here, I've allocated this as an implant case, loaded the correct scan body, and everything will kind of like match up. And then basically you just wait, and here you go. That's the initial design that you get. Of course, if it's provisional, you can just simply go ahead and print that. But as with most other CAD programs out there in the market, you can actually manually adjust it. So here I'm taking a bit of my time because I kind of just want to show you that all the kind of like the tools that you can use with this particular program, right? Right. So here I'm just kind of bulking up that facial surface to kind of like fill up that deficiency or that defect labially. So this is kind of like what the restoration looks like. Right. And as I said, you can spend as much as you want with this or as little as you want. At the end of the day, you have, something there ready to use. But for demonstration purposes, I'm taking my time with this. Right. So then, of course, I can export this, and we're going to print this, of course. And instead of the Asiga printer, I'm going to use the Midas in this particular case. Yeah. So just to give you a better idea what that restoration looks like, without all the stuff in between. So screw retained prosthesis. So yeah, oh yeah, here we go. So yeah, I'm just loading it onto Rayware, which is a cloud-based 3D printing slicing program specifically for sprint ray printers. And I'm going to be printing it on my Midas out of Crown HT resin. Beautiful material. I think it just got CE approval in Europe, and it's just got TGA approval in Australia. I think it's 60% filled with ceramic filler content. And yeah, it's a really nice material. It polishes up beautifully, which is really important because, as I said, anything that contacts the soft tissue must be polished to a fine shine, and you must not glaze those particular areas. Here, very interesting, I'm printing two. It's just a habit of mine, just printing a spare at the same time. Anyway, these capsules are single use, so I'm just printing a spare because you never know when you need that spare. Right, and yeah, as you can see, it's going to take me 10 minutes to print really quite tall restorations. If it was just a molar, it'd probably take, yeah, about 7 to 8 minutes. That's how they come out, freshly printed. And of course, you wash it, cure it. I just put a little bit of glaze super gingerly, and then of course I've run that in my nanocure. And this is the results, okay? So I think it's not too bad, considering it's all done in the one appointment. And yeah, I think overall patient was quite happy, considering that it's a very stressful situation to start off with, right? But I think, yeah, the patient's learned his lessons wearing his splint now. It's like God now. And, this is where, as I said, AI is really shining and will continue to improve with time because it'll almost mean that a lot of practices no longer necessarily need to rely on expensive software like Exocad or 3Shape. I'm not saying that they're bad. I have actually both of them. But for the general user who doesn't want to invest in a whole lot of time, money in these programs, only to use 2 or 3 functions, I think AI-driven software is a really good alternative and will continue to become a good alternative for many users out there in the market. Right, so points to note, at this stage, if you're going to use this app, you really do need as good of a scan as possible and a relatively well-defined emergence profile. So it's perfect for immediate anterior cases where the root is still there, you've taken out the tooth because you still have that socket. So it kind of acts as a nice emergence profile situation. I think if you've got open flap, and you combine that with poor scan quality, bleeding around the place, sometimes it can be a bit hit or miss. All right. So if you want a bit more predictability, Try also has that scan and smile service, which gives you something within a 24-hour period. Depending where you are geographically, probably if you're in Europe, you probably get it much faster. But I'm in Australia, we're so far away from everything else. So realistically, I'm going to be waiting for 12 to 24 hours. If you're going to be 3D printing these, you must use the Matrix 3D print library. It just gives it's just a little bit more tolerance in the screw channel area, just to take into account that there are a lot of 3D printers out there in the market, some of them more accurate and precise than others. So this Matrix has come up with a specific 3D print library for CAD programs like 3Shape, Dentbird, Exocad. So if you're going to be 3D printing certain restorations, you'd be using that particular library. You're going to hand wash these in alcohol or IPA. You never want to submerge these restorations completely in IPA, which because the ceramic content can actually degrade very, very quickly, and you'll end up with a very frosted appearance of your restoration, which you have to kind of buff out and polish out. This is going to change very soon because you'll see many companies come up with alternative washing solutions. So Pacten or Rodin is coming up with one. I think Ceramica has their own spin on it, and it's been in the market for, I think, 4 or 5 years now. So non-alcohol based washing solutions. So I think that's something to keep an eye on. And very importantly, I've got this photo in the middle of a freshly printed and washed Tri-Matrix provisional crown, and I've got the screw actually inserted in it, but not in through the top. I've actually inserted it through the bottom. I insert it through the bottom because I want the internal or that screw channel to be cured as much as possible. And if you have the top part within the screw channel, theoretically light can't get access to it. So I cure my provisional crowns with the screw inside because, as with any composites that cure with with light, you do get a bit of polymerization shrinkage, right? So yeah, I cure it with the screw inside, so my screws will always fit. Right. So I think that's basically I think smack bang. I think an hour. If anyone does have any questions or wants to know more about the TriMatrix system, by all means, you can scan this QR code. I'm sure there probably are quite a few questions. Because it is quite I guess barrier breaking material. I think Holger, are there any questions
Yes.
for me to answer?
Yeah, Andrew, first of all, thank you very much for this presentation. There is for sure a lot of questions, and it's a
Yeah.
big topic. I
Yeah.
think for 1 hour to start from the scratch on with design to really a 3D printed crown, there's a lot to do. I would say, like, because your topic was like it's time for the red pill, and we're talking about the matrix. And before we answer any questions, I would like to ask you if you would like to answer these. I think you can see it. That if you
It's
are
gonna be
ready for the
interesting
red
now.
pill, we started this. We started this. Very in the beginning when we start with the matrix system, we said like, are you ready for the red pill? Because the blue pill is for it's an analog workflow, and the red pill is as the digital workflow. And I hope you're all ready for the digital workflow. So yeah, two words that the question and answers. I will share my screen, and then first of all, there was a question, and maybe I can even answer it. There was a question. Yes, can I only print then or design in the eye crown straight screw channels? This is
Uh,
yeah. Answer
yeah,
maybe
yeah.
you.
I think well, right now I've only designed straight channels. I know the angulated screw, the 2.6 millimeter, the 2.6 screw for Tri is actually preloaded onto the AI Crown software. I haven't honestly tested that out, to be frank. Because I generally, maybe I'm lucky, but in the grand majority of my cases, I have, straight access. But I know for sure that the angulated screw for Tri is preloaded onto their library essentially. So whether or not you can actually manually change, that angulation, I'm not sure yet. I think I don't see
Yes,
why
yeah, yeah, I can
that
answer that,
can't be.
Andrew.
Yeah,
Yes, we have an angulated screw channel possibility. That's really great with 3D printing. We can basically 3D print everything. And yes, the only thing in the AI software, you have to choose the right screw. As those of you who use the system already, the 2.8L screw is the classical screw. I saw that in your presentation, Andrew, that you use that most of the time. That's a classical prosthetic screw to use. And if it's an angulated screw channel, you use 2.6 screw. That's what you have to tell the AI, because the AI can't
yeah,
know which platform of implant you use, which angulated screw you want to have. But then when you tell it to the software, it will create this. And then the next question also, is AI possible to use for 3 unit or further more bridge based designs? I think I answered that also quickly, because
mm,
we have already a workaround, but it will be, as Andrews mentioned, I use your words, it's not a year's developing time in these digital workflows. Everything goes so quickly, and we are able to design already now with this AI software 3 unit bridges or even 4 unit bridges. It is there not that self-explanation, so you have to add a little bit more things in this moment. But I think when the next update is coming, you are able to even easily the design, or the AI designs for you easily a 3D a 3 unit bridge. That's not a problem.
yeah.
So
So yeah, and with this program, it's not just for implants, it's for teeth. And actually the 3 unit bridge tooth-borne, not implant-borne in this program is a bit more predictable. But because they only just introduced implant-borne restorations, I would say in the past kind of like 6 months, not too long ago, it's just going to take time essentially. But the good news is that it's not going to be that long. We're really looking at months rather than years, to be perfectly frank.
Then, because we are a little bit running out of time, there was another question. How do you think will be final restorations possible? Yeah, maybe some comments of you about final
Yeah,
restoration printed.
I think definitive restorations right now, I think milled ceramics are still king. I think you're still going to be milling your definitive restorations in ceramic. That being said, the beautiful thing is that if you design it, for your provisional, you can, which is 3D printed or milled, you can use either the same design or something based off that design for your definitive restoration. So I think right now I would say there's still milled ceramics is still king, but who knows where printed ceramics or printed composites take off.
Yeah, like the Midas printer is already printing in a different technique, and I think this technique allows to add more zirconia particles in the future. And I think that's why we all strongly believe, sure, milling machines will be better too, will be milling differently and so on. But the 3D printing helps a lot. And as Andrew really nicely explained, the sizes of the printer and all those things for chairside, immediate temporaries for sure is possible. And this ceramic crown material, which Andrew described, has a high potential of zirconia, of ceramic, and that gives a very strong crown. And if you do it like Andrew did it, that you print two crowns in one and keep it, even the patient, maybe it breaks the crown after half a year, you can just like call him and he comes to your office and you have just immediately a new crown. That's also the difference about 3D printing. Yeah. Okay, so I think there's some more questions, but we are running out of time, and that's why I would just like thank you again, Andrew, and introduce you anyways to the third of three webinars about 15 minutes scan and smile. Workflows, and this will be taking place at the March 17th at 12 o'clock again with Dr. Federico Rivara from Italy. So please, if you want to sign up immediately, you take the QR code on the right side. And to be ready for the next webinar, he will show in his webinar the first AI-based three-unit bridge. That's what I already know about his presentation quite soon. And the last thing I really would love to announce is that we have a course coming up the 7th and the 10th of May, not only with these phases you see there, but it's in connection with the digital smile design, which is done by Christian Coachman and Anini Brothers in Italy. It's based in the Ferrari area, so we will have a nice excitement to go to the Ferrari Museum and so on. But this course has limited places, and it's a really amazing course. It's called the Scanner Festival. You will have there different providers of different scanners. We talk a lot about different ways of scanning, different ways of photogrammetry and so on. For me, I was last year a part of this course, and I have written down so many things about digital workflows. So this is quite an interesting course. Please get in touch with us. We do not have set up a QR code for this now, but if you are interested to be a part of this course coming, please reach out to us at TRI. And so that's my last slide. I say thank you again, Andrew, and we will pass to you guys the last questions which we couldn't answer. Thank you very much. See you soon.
Okay.
Bye-bye.